welcome to this new episode related to coding development by Ozzy. This series, it won't be a long series, but it's called the tunnel effect. Let's say demo coding, because this effect is used in demos, basically. With me, as always, we have Ozzy. Hello, Ozzy. You are not mute. I am muted you, so you should talk.
Yeah, good evening, good night, depending to where you are.
Yeah, you
Thanks
need
for
to.
having me.
You are far away from the microphone though for some reason.
I will just.
Yeah.
Is it better now?
Yeah. It is. I think you had your hand on the microphone on the side because.
Oh, probably yes. I still don't know which microphone I'm using, if the one on the laptop or the
No,
one in the
no, you're
headset.
using the one on the headphones, I think. But if you put your hand where the headphone is, you
Oh,
cover it.
here, like this.
Yeah, yeah. Anyway,
Okay.
so it's a new series. It's a new stream. Hello, Dogster. Anyway, hello, Hound Dog. Hello, Dogster. Hello, School Coder. Okay. Um. So yes, it's a new series. It's a tunnel effect that you have seen in demo coding, and Ozzy is going to show what he did and what he's trying to achieve because it's not yet complete. Okay, as always, we are showing where we arrived with each episode. Let's say that.
Yes, I will let the audience to finish my job. What I did.
Yeah. So yes, it's yeah. I think I'll hope you like it. Um, and it's one of those things that we have seen recently quite a lot in demos. I guess. So as always, let me go to my browser, giving that it works. There you go. Um, you will see Proton. And it's not complete, and it's not optimized, and there's lots of things which are. I know you will do better, Proton, but this is a learning. Uh, how to say learning? There's a word for this. Learning practice, if you want to say that. Um, Learning experiment. So yeah. So first of um, uh, all I ask is you subscribe, follow my YouTube channel, and put likes on my videos. I do have some videos that I need to update to on my channel, but because I was traveling, I didn't do anything. Remember that under each video there is the more button that can give you access to sources. Proton, I'm going to let Ozzy to explain what he did instead of me, so that I do not, advance of what he just said, of what he's
Yeah,
going to say.
don't spoil.
Yeah. Remember that it will take you to Mega, where you can download the sources for whether it's Amiga or Commodore 64. Please note that I have my Facebook page, but also I have a Facebook group and the Phase 101 Facebook group, and also the Commodore Dev Facebook group, where you can meet most of the developers that I met for Amiga 38 also. So please subscribe, follow these Facebook groups. Besides that, you can send me messages on YouTube, but the best way to get in touch with me is Discord. Okay, is the best way to. I mean, I answer much more faster than if you send me a message on Facebook. Ozzy, Ozzy is very humble, guys. Okay, it does work, but it needs its tuning. Um,
It's a start, let's say.
yes, it's a start. Everybody started from zero, so yeah. Um, as I said, please join my Discord if you want to get in touch with me. But if not, if you don't like Discord, you can also reach me on Telegram, and this is growing since I went to Spoleto in Italy for a Passion Amiga, and now Amiga 38. All of a sudden, this is flourishing. um, and it's good because it's good to have another channel where somebody can reach you. Besides that, if you want to go the extra mile and support us, then you can either join my Patreon or my um, Coffee. Um, you can join there and you have access to, I think Coffee says, yeah, 264 videos. Um, if you want to join there. Remember that at the end of this month we have the shoot 'em up game jam that will be finishing, which I have half of a game for this ready. It's not ready yet, but I hope to finish it by the time um, this game jam finishes. And of course, I need to continue the tank game for the Amiga. So those two will continue as I will show the eventually I will show the game, but for now it's a mystery because I'm learning something also at the same time. I always use a game to learn something, so that's the aim of it. So let's go to my screen and we pass the speech, the talk, the presentation to Ozzy. He's, as I said, he's going to talk um,
About what I want
yeah,
because I'm
yeah,
some sort of
about this tunnel
dictator.
effect. Yes, yeah, about this tunnel effect
Yeah,
and
yeah.
the
Uh,
issues he currently have or he might have.
yeah, it's also for me a good chance to talk about my problems, also to see if anyone has suggestions and how to proceed from there, because this is a quite common effect, and probably a lot of people already did that far better than me. So this is just my first approach. While I was doing my artsy car game, I found on the internet this article about the tunnel effect on the Musin, and I just gave a quick read and I bookmarked it and I said, okay, when my game is done, maybe I can try to replicate the focal points of this document on the Amiga because, as usual, um, what I read is not Amiga related. It's just a generic with pseudocode tunnel effect, and I want to try to port on the Amiga. And and I can show you the page. Can you please open Google for me, Face,
Give me a second.
and so that we are on the same page. Probably some of you already knows this website.
So let me switch again. Yeah, and where
And
shall I go?
on Google, just type tunnel demo effect.
Yeah, this one, the first one.
Yeah, let me check. It's a tunnel effect? I think it's the second
Second. Okay, okay,
result.
yes, yes, because I remember you showed it to me. Yeah, let me make it bigger.
Yeah, I'm not going to explain all of this read because it's quite long, but what I can say is that it's very easy to understand. It doesn't require a lot of knowledge about mathematics and so on. It just gives you the main steps on how to build this tunnel effect. And big disclaimer, this is not a real tunnel. What is doing here in this paper is just teaching us to how to take a texture and then to, let's say, manipulate the texture and deform it according to a transformation table, because it's not a real 3D. It's something that it could be useful for us because the Amiga has not a 3D GeForce card inside. But with this, let's say, simple tricks, you the final result, the final outcome, it's something that really it gives you the impression to be inside a tunnel, and it's a texture tunnel. The point is, it's quite hard for the Amiga to render this. This is something that it's mainly focused for a PC, for example, because if you have a chunky screen, it's something that you could do easily. And if you have mathematical libraries, it just, I think it's almost trivial. But on the stock Amiga, it gives me some challenges. And today I will try to explain what I did in order to reproduce this tunnel effect, of course with limitations, because I cannot display all 256 color. I can't go into such high resolution. I have to, as always, the Amiga user have, the Amiga programmer have to do compromises in order to have this running. But um, the the point is, the Amiga programmers usually, it's like a challenge for them. Try to make an effect which is meant for a PC and try to demonstrate that the Amiga can do it at least with the same performance or even better. And that's my point. I just want to translate this page that you are seeing into the Amiga world in assembler. uh, I don't need the C here because there is not much to calculate. I need just performance. And if you did you try to run my executable inside the
Yes.
zip that I gave you? There is the
Yeah.
executable. Maybe you
Yeah.
can show where I'm right now.
Yes. It's a standard A500 because it does run better on an 8030.
It should run much better.
Yes, it runs a lot better on a 680. I tried it.
Try on your V4. It should fly.
Oh well. On the V4 for sure it will fly. So,
Oh, you're saying it's 1.3?
this 1.3, yes. Amiga 500,
I,
no?
I didn't test on this OS. I'm glad to hear that it's working.
There you go.
Yeah, that's the effect. And if you notice, it's going very slow because it's not 50 frame per second. I'm just really, I need some better Amiga in order to have full frame rate. But at least this can show that my math is correct, because this is exactly step one for me. So achieve this particular pattern. And from here, my idea would be, let's make this effect more interesting. Maybe if I change the center of the tunnel dynamically, I can create something, or some color cycling, I can create some nice effect. And what I would like to have at the end is something that fits into 4K. And this is impossible, probably, I don't know. But right now, the compressed executable is, if I'm not wrong, is uh, 2800 or something like that.
Yeah,
So
we can check.
yeah, check it. But I remember last time I checked, which I'm not hitting the 3000.
2908.
Uh,
Sorry, TC is 2892 because it's TC what I ran. It's the
yeah,
last one.
yeah. But consider I have a lot of unused code inside the executable. There are a lot of things to strip, so I can go down a little bit. And what I would like to do is to add maybe some effect, maybe a scroll text, because originally this project was meant for Italo Disco, which is an Italian magazine by Carlo. And he asked me to do something. I don't know if we'll accept this entry in his Italo Disco. I don't know if he likes it or not. On the first issue, he used some 3D stars, and maybe some way in the future he could use this effect as a presentation screen in order to launch the demo disc demos.
Proton Fig. Yes, I know the game, and I know because it was. I think also the game, the effect that it uses was in a demo also, if I remember correctly. Yes, but you're talking at levels that we are still beginners. Let's say that.
Also, I think Jump is meant for AGA.
Yeah, that's also true. Yeah, you're right, actually, Ozzy. Yeah.
Yeah, the things are quite different, because if you can go with a chunky to planar algorithm,
Yeah.
things are a little bit easier probably. But yes, Jump is a great game, and of course,
Yeah, look,
I'm not comparing my work with Jump.
it says Amiga 1200 auto processor 40 megahertz. So yeah, and this is alpha
Yeah,
version. Yeah.
yeah. So yeah, it's a very good game. This one,
Yes.
I saw it. I don't have it, to be honest. I didn't buy it. Maybe in the future I will, but it's very nice. For me, going into such detail is a problem. Let's say with a stock 500. This is why I don't see much demos using the texture tunnel. They use always dots, mostly dots, for what I saw, because yeah, textures are a problem in a planar screen. You have to cycle and to write the pixel through each bit plane, and the stock processor, it's really a pain. So I think we can start with the
Yeah.
slide. I can just
Yeah,
explain what I did.
give me a second to move the Amiga out of the way and also the browser.
Did you also try the demo with higher spec machine, like an
I
EJ
tried it.
machine?
I tried it on, but but now it's a bit a problem for me. But I tried it on the Amiga 1200, and it's fine. Also,
Okay.
of course, it runs faster, and I tried it
Yeah.
on a Amiga 1200 with a 68030 also. So that's why I told you on 68030 it's okay. It's very okay.
Okay. What I have in mind, I remember that WinUAE has this debug feature that will give you an image representing the DMA access, and it should give you an idea where to work on optimization. So uh, there is still something that I can do. I don't know if hitting 50 frames per second is doable. I doubt it, but I will try to do some optimization for sure.
Yeah.
Okay, so let's go to slide number 1. And if I remember correctly, because
And there you
I
go.
used
You had the link in the notes. I
oh
forgot.
yeah, I forgot.
I
Forgot
forgot.
about
I
it.
saw it today and I forgot it. But yeah.
Yeah. So this is exactly the recipe, ricetta in italiano, I think.
Mhm.
What you need in order to achieve this effect, and as you see, not much. You don't need much. You need a texture, and I used my own texture. It was programmatically generated, but of course, if you have some planar image, you can do the same. It's not mandatory. Um, in the in the document, they are suggesting to use a XOR texture, which is a very fast, just for testing purposes. Then you need this distance table, which is a big table. It just tells for each pixel on the screen what's the distance to the center of the tunnel. And so it's quite easy to do it. An angle table or rotation table, I call it angle table. It's the same, and this is what it's deforming on the y-axis. So you have the combination of these two tables just tells you which pixel to print on the screen. And these are pre-calculated tables because there is no way you can calculate these tables on the fly on an Amiga. I really don't see how. And then you need some processing power because in order to render on the screen such a big image, you can't use the copper or the blitter. I don't see how to do it with the custom chip because you have to render each pixel one pixel at a time. It means the blitter is good when you have to copy big chunk or big rectangle of data from one place to another. But in this case, I don't have a big chunk. I could use the blitter, of course, but I would spend so much time loading the blitter register that really makes no sense. I would just prefer to blitter directly on the screen. So this is the recipe. So go on with the next slide, and so you can see my implementation, and
yeah,
you can yell at me, "Oh, you don't do this."
I was going to tell you to, if you have time, read what I sent you, because then you will see that you can do it with the copper. What we were talking
Is it
before.
doable?
Yeah.
And did you write me on
Yeah, it's on
Telegram?
Discord. Don't worry, I will tell you later on. So that we don't,
Okay.
so that we don't lose time. But yeah.
Okay. Sorry, I really have not already updated with.
Yeah, sure.
this program.
Don't worry, don't worry.
So this is the first step. The first part of the recipe is the generation of this XOR texture. And as I said, it's very easy to generate. There is also a Wikipedia page that will just explain what is this monster and how to create one. It's good for testing, and it's quite easy to implement on a M60A machine. And above on the screen you have this it's C code. I didn't use C code on my program, it's all assembler, but I put it here because it just gives you a better idea how to build this texture. You just iterate for each Y of the screen, of the texture, sorry, and each X of the texture. So for example, on my example, you saw a 16 by 16 texture. So it means the first iteration goes from 0 to 15, and the second it goes from 0 to 15 as well. And then we have this is a uint8 type. It's just a byte, and it's the result of X, the X counter, XOR Y, and that's it. Very easy. And if you don't remember what XOR is, I put the truth table. I think it's called like that. Truth table, tavola della verità in Italia.
No. Yeah.
And if you see it, it's just a regular OR, but there is one difference. The only difference is the last case. If bit A is 1 and bit B is 1, then the result is 0. Instead of a regular OR logic operator, you get a 1 here. And there is also a page on this lowdev.org website that it gives you more ideas about the XOR.
Yeah,
XOR texture.
I can show it if you want.
Yeah, if you can do it.
Please, no? Here it's saying better textures and
yeah, these are, of course, this is the final outcome, I think. It's the last part of it. I think it's on the top, where it's talking about the XOR texture.
This is the bottom, so
yes, it's
yeah.
Exactly. But you have to go to the top. I think it's the first paragraph. Yes, how it works. First, you need a texture, which is a texture of the size of the tunnel. The animation of the tunnel isn't calculated on the fly by animation, but it's pre-calculated. Maybe I'm mistaken. I didn't read this. I think it was on Wikipedia. I don't remember. But there is somewhere here in this website which is explained quite well. What is the point that I want to go is that the number of colors here is proportional to the size of the texture. If you have a very big texture, you get a lot of colors. So if you have a very small texture, you have just a few colors. And since the Amiga has not so much colors, the maximum is 32, but I don't want to turn on each of the 5-bit planes because it costs. I ended up with just 2-bit planes. So I have a background color and 2 colors in order to build the tunnel. So it's a black and white tunnel on a gray background. That's it. And can you open the VS Code and show my code in order what I did to?
Yes, but now you have to give me time. You can continue talking and I'll do it while you're talking.
Oh, okay, but I don't know what to say. No, yeah, why 16 pixel? The texture is 16 pixel because the screen where I'm willing to draw this texture is quite small. So I have to find a good ratio. And of course, the width and the height of this texture must be a power of 2 for multiple reasons. So you can't go with an arbitrary resolution of the texture. You have to always go to powers of 2. Otherwise, you get the image, the tunnel, which is not exactly filling the screen. That's the point. And I said, this is pre-calculated. So you have to pre-calculate the texture, you have to pre-calculate the tables, and then the tables will just tell you for each pixel which one to print taken out from this XOR texture. That's the point of everything.
Okay, so now let's go to the
I see that
visual code.
Carlo joined the stream.
Who?
Carlo.
Ah, hello, Carlo. See you soon. So, yeah, there you go.
Okay, and as usual, the startup routine it's stolen by RamJam, of course. It's
it's
the very same routine that I used for the triangles
yeah, it
demo
is
in
my
the stream.
version, modified version of Fabio. No, that's what you are
Yeah,
using.
I don't remember because it's just a copy and paste of the triangles demo, and I
Yeah,
liked it
you are
because
using.
it's.
I think you're using mine. I mean, mine. It's Fabio
Mm,
modified. But yeah,
I think it's something that I took from Fabio and then I deleted something in order to save space. So it's not exactly, but
yeah,
it's
whatever.
the main concept I
Mine
will
is in
use
the
the same.
car racing for sure. Mine.
Yeah,
Yeah.
you're
Okay.
is in the car racing. So here, just go. I will tell you where. I will open my editor because so I can give you the
Oh,
exact
hello,
line.
Dario, and hello, Z3K, of course.
Also,
Italo
Dario
disc,
joined the stream.
Italo Disco loves fake Ozzy tunnels.
So I don't remember. I have a problem with my directory tree. I don't remember where I put my code. Okay, tunnel and tunnel dot tunnel dot s. So I will say that there is. There is a label which is XOR underscore texture at line 208.
Yeah.
Which is quite trivial. And I'm looking for some methods in order to shrink it down because probably I'm using too much instructions. And in the comments at the top, there is the C code that I'm trying to make a translation. And I want also to challenge Bartman to see which one is better. So which version will be faster and the smaller at the same time. But for now, it's just let's say a proof of concept in order to see if things are working and my math is working. So we have a double iteration, and the first one is for the y coordinate, and the second is for the x coordinate. And then we have A2, which points to texture data. And this texture data is just the address where we want to build the texture, and that's it. And what I do here is for each point of the screen, I at line, it's line 238, there is a AR.W instruction. And this is very handy because the M68000 has this particular instruction which does exactly the XOR bitwise operation. And
sorry to interrupt you because I missed a comment. Proton, I did try to do jumpgame.com, but it didn't give me basically page not found. I mean, I couldn't go to that page, and I didn't know that Serrato did it. That basic routine. So thank you for the info. Sorry, Ozzy, you can continue.
Okay. So I was telling you that, telling everybody that I have this at line 231, I have this ER instruction. I just get the result. It's the correspondent of so it's just an error, XOR. And this is the color of the tunnel. Now, since this particular texture just gives you more color if you go up in resolution, and I only have 2-bit plane that I can use. This means, let's say, background color is 1, and then the remaining two colors are meant for the tunnel. This means I just have to do some adjustment. I want to say, for example, if the color that is calculated by the XOR is less than some particular value, then the pixel is white, let's say, color 1. And otherwise the pixel is black. And this is why I put this if statement at line 234. And you see, there is some mess here because I was trying to have some visual representation of what I was doing. There is a stroke command, which is telling the A processing routine, please use color 1, and at line 239, there is stroke 2, which is telling, please use color 2, and that's it. But this is not a good approach for me because remember, when I on the game loop, so every time I have to copy a pixel from this texture to the screen, so to the actual bit plane, I have to do some operation. I have to find the correct byte address, and then I have to select the correct bit. And this is a lot of work. In order to avoid this, what I did, I just I replaced my point function with the clr.w at line 236, and the other is I think it's move.w fff at line 240. And this is just because I want to have all the data aligned or at word level. So I'm just printing the texture at 16-bit each time because I don't want to select the byte and then select the bit. It's too much pain for me. Yeah, I can write it, of course, but I need the performance, and this is one way to achieve performance for me. So the final outcome of this routine, it will be that you have into label texture data, you have let's say it's 16 per 16 multiplied by 2 bytes of data. And then this is the data that I will copy to the bit plane. I don't know if I was clear enough, but that's what it is. If you for example uncomment point, you should see the XOR texture on the screen. If you are able to compile it, you can do it right now. Otherwise, doesn't matter. I don't know
Okay.
did
No,
you
no,
try to
no, I did
compile
not
it?
prepare it to be able to compile it as it is. No.
Do you want to try it, or just we can go on and be?
Because I did not, your make file, I did not modify it like I usually do.
Okay, it
I
doesn't
didn't,
matter.
given the time that we had, and then I completely forgot I needed to do that. So yeah, the make file is
No,
not ready for it.
next time.
In the meantime, though, give me a second because Proton sent something and I want to show it if it works. Oh, there you go. This is the tunnel effect on the Commodore 64. So,
Yeah, it's very nice.
yeah, it is, it is. So, this was done by Sarato, no? Serato, sorry. Um, Proton. I I see a pattern here in this one. Let's put it this way. Okay. Yeah. So, yeah, this is for the Commodore 64. If the Commodore 64 can do it, so can the Amiga. Yeah.
Yeah, of course. But what I'm trying to do is just probably I'm taking another approach since I don't know how the Commodore 64 works. I
No, it's
cannot
even
really
worse.
appreciate how all this stuff because I
Yeah,
don't know the technical
it's even more
challenges.
difficult. In a way. Uh, yeah, but let's not go there. Yeah, your
Yeah, I wonder if the C64 demo that you show can alter the center of the tunnel in real time.
I right now I doubt it, but I mean maybe Protonfic can comment. Yes,
Yeah,
yes, Proton. Okay, so let's put it back.
yeah, because my goal was just to say have this, let's say, animation, which is the tunnel which is running,
Mm-hmm.
and during the game loop, so at runtime, what I have in mind is to change, for example, the texture, or maybe change the projection table on the fly, and maybe some cool effect comes out. I don't know, maybe. But that's my point. I want to do not use. Yes, let to try to do not use pre-calculated stuff as much as possible. That's my goal. Even if, of course, I have to pre-calculate something here. The tables are pre-calculated, and also the the texture. Now I would say the hard part. There is a generated transformation table label. And I think
Is it further
if
down?
I will give you the line number, which is 250.
250. Okay. Yeah.
So in the comment, you see the um, C code, which I, let's say, copied from the website that I told you before. And this is how the transformation table is built. And this is the transformation table on the x-axis. And if you see, okay, it's, let's say, it's my version. It's not a copy and paste. It's what I used to pre-calculate the table. But what it's using my program, it's not the output of this C code. It's just I did it just for have a comparison. So my program outputs some data, the C program outputs some data, and then I compare this data with my assembler routine implementation, and I compare one byte by each time if there is too much difference, because I have some rounding problems in order to, because I don't have the FPU available. But if I see that the values are more or less the same, for me the implementation is good. This is how I proceed. And what this routine does, it builds this table, which is I think it's quite trivial, because we have this distance variable which holds the distance of each pixel relative to the center. So it's just I call it Teorema di Pitagora. I don't know the translation in
Say it
English.
again. Say it again. What was the word?
Teorema di Pitagora.
Ah, Pythagoras theorem.
Yes, exactly. It's just the distance. It's just a triangle, and I'm just calculating the distance of each pixel to the center. The x minus width divided by 2, it should be the center of the screen, and the center of the screen on the x-axis, and the y minus 8 divided by 2 should be the y-axis. So I'm just building this table. Each pixel is represented by a value, and then I just do the inverse. I say I divide text height for the distance. So I have a very small number which must be multiplied by this ratio x, and this ratio x that just gives you how many rings you have in your tunnels from the outer layers toward the center. If you increase this value, you get this ratio x value, you get more rings. So it's just a matter of personal preference, personal taste. If you want more complicated tunnel, just increase this value. I picked the value 30, which sounds nice to me, but of course, this is another parameter that I could recalculate around time. Of course, not the full table in one frame. I could say, for example, each frame change the ratio x and calculate the new table, and so the image should morph into something a little bit different. That's the goal. And then there is another variable which is called inverse distance modded, and it's just the same value, but it's the reminder of the division per the texture height, because you don't want to go to outside the boundaries of the texture. And that's it. this is what goes into the transformation table for the X. And what you see below, starting from line 267, it's my assembler implementation. And as I said, I have very similar results. I'm not going to explain this routine because it's quite long and it will be very boring. So I really don't recommend this as a reading for the night. But yes, when you exit here, you should have the transformation table ready. And of course, this is calculated before the loop, the main Gale loop. One, just one thing that I want to point out is at line 295, there is
95, yeah.
the execution of the square root. This is another routine that I have, and it's very, very small, and it's also quite accurate. It's not perfect, but it gives very good results. ProtonFig gave me
Yeah, I was going to mention it.
another,
Yeah,
yeah.
I recognized it that this is Proton. Yeah.
No, this is, I don't think it's Proton this.
No, I thought it.
I didn't take it from Proton. I took it from somewhere else. And for me, it's a good alternative because I think this is even smaller. I didn't do any performance test to see which is more accurate or less. This routine gave me quite good results. So thanks to this routine, I can pre-calculate runtime all my distances, and I don't have to include with Inkbean the raw data that would have bloated my final executable a lot. So this is a very nice finding, and this is about the first transformation table. And the second transformation table is at line 400. Please go to line 400. You passed the 400. Yeah, and it's an include. This is the other include.
Yeah.
And I will tell you why I didn't pre-calculate this table. There is another file in this repository which is called, it's a C file.
Yeah, transformation table C.
Yeah, open this file.
Yeah.
There is a function which is called generate transformation table Y.
There it is.
Okay, and there is at line 32, there is this double A-tan distance equals blah blah blah. My problem is that I don't know how to translate this with 68,000 assembler, because I don't have this A-tan2 function. I don't have the correspondence of the SQRT and implementing A-tan2 will be quite, I don't know. I didn't try it because I don't have the knowledge to how to calculate it. And this function, by the way, you already know what it does. I already used the same approach with my artsy game in order to get the angle of a vector. And this is more or less the same problem that I'm trying to solve it. And with inside the game, I just built up more or less a pre-calculated table, and this is the same approach here. I really would like to get rid of this table, so to avoid to include the raw data, but this instruction is really giving me hard time. And so if any of you has an idea how to translate this line into assembler, it will be very appreciated. And I just need a function that takes a y and an x and returns the angle, and the angle must be divided by pi. So I need some result between -1 and 1. That's my problem. And of course, since I have to build a table and include it, I just pre-calculated everything. So I have here my table already finished in few lines of C code, which is very. I don't know how Bartman deals with this type of code. Maybe there are some routines inside the Bartman that just let you use 8 and 2. But yeah, my problem is I have two values and I want to have the value of an angle. So it's the inverse of the tangent function. This is what I need. And C gives me that, and the RamGem book doesn't. That's a problem. And that's it. This is the other pre-calculated table, and then I will say we are done. There is just the rendering part, and I can point
Shall I
out.
go to the slides, or what do you, or what do you
Just
want?
go to the screen because the slides are just describing what I'm saying, so we can forget about the slides, I think.
Okay.
And I just want to end this talk with the go to line. Go to line. I don't know. I'm lost on my code because I'm really dumb. Go to line 128, 21, 121.
Yeah.
And yeah, and this is where this transformation table are read. And A3, if I remember correctly, points to the distance table, and A4 points to the rotation table. And what I do here, I just 1 pixel by 1 pixel, or let's say 1 coordinate by 1 coordinate, I retrieve data from these tables, so from chip RAM, because that's where they are stored. Of course, if you have fast RAM, this should increase performance a lot. But anyway, the point is I'm getting from RAM this value and I store into D2 and D1. And then I have this frame counter, which is the correspondent of what pellicles always use, which is called the T or time or whatever. It's just a value that is increased by one each iteration, and it's very useful in order to have this rotation movement to give sorry a value that represent where we are in time. And I would say that's it. So after that, you get your values from the table or from the tables. It just starts the rendering. And for the rendering, again, my first approach was to use the plot point function by RamGem. But this plot point function has a problem because every time that I use this function or this routine, it starts calculating the address of the byte, and then it negates the data register containing the bit value, and then it just says bit set, bit clear, what you want to plot into the screen. And this is a lot of work. What I was trying to do at the beginning, let's say that one Amiga pixel is 8 logical pixel on my head. So each pixel will get stretched on the x coordinate by 8. And this resulted in a crash because I was going far beyond the bit planes. The resolution is not big enough to hold the whole image if we are multiplying it. So what I did, I just reduced each Amiga pixel is now converted into 4 pixels. Salute.
Yeah.
So what I did here, it's a very, let's say, ugly solution, but it works so far. It could be implemented better. If you look at line 145, there is a bit test, and the bit test just tells me if we are plotting an odd or even x value. And in one case, I just write the upper part of the byte, so the high nibble, and in the other, on the else branch, I do the opposite. So one time I put ones into bit plane 0 and put 0 on bit plane 1, and on the other case I just do the opposite. And this is what I achieved in order to render all this stuff. And that's really it. It's not complicated at all. It's very easy. I think even beginners can do something like that, because really there is no math involved except the ATAN, so the arctangent function, and the other is just addition, subtractions, and Pythagoras theorem.
Yeah, Pythagoras theorem.
Pythagoras theorem.
So if I go to the slides, can I go to the slides to see that we have said you haven't missed anything?
Yeah. Go back to the slide.
Yeah.
I don't think I
mean, you
missed
don't have a lot of
anything.
slides, so I guess you mentioned this because I remember you mentioning this.
Yes.
Yeah.
It was
The distance table.
exactly. So
and this is
good.
the angle table.
The angle table. Yes, 8 2.
Yeah.
My nightmare.
Yeah.
This is really a problem.
And now is the rendering part, which I believe you explained.
Just explained.
Yeah.
And that's it. So as I told you,
Yeah.
I will work a little bit more, put an extra effort on this effect to see if it's possible to have some optimization. And if something nice comes out, I will try to make it more interesting and hopefully submit to Italo Disco. That's the plan for me.
Okay.
And don't have much time to work on that because my due date is approaching for the Flash party, and people started me sending new tracks, and I have to check each track. So it's a lot of work.
So basically, I assume you have finished, no?
Yes.
Yeah. So
if you don't have questions, yes.
No, it's fine. Guys, thank you very much. Hope to see you in the next stream of mine or that of Ozzy. Okay? Thank you, guys. See you. Bye-bye.